Hello everybody, welcome back to the session. Today, as I said, we're going to see electrical machines. You can see there, right? Electrical machines Friday. So yeah, I'll be taking up the questions today from electrical machinery textbook PS Bhimbra. At the end of the book, you have a lot of very good questions. Okay, so I'm going to discuss all those questions. Okay, in this series of videos, I'll be covering all the questions one by one. I recommend you guys, before coming to this, you try to have a good idea about the machines, because I'm already given the schedule. I have given the schedule already. You just check the schedule, okay, and according to the schedule, you have a little preparation beforehand. Okay, just refer to the points. Okay, once you refer to the point, then it will be easy. It will be interesting for you to solve the questions. Okay. Shall we start? How many of you are there? Did you hit the like button? Today, I'm announcing an offer. Okay, I'm announcing an offer. Once we reach 100 likes, this video, during this live session only, once we reach 100 likes, then I'll unveil a good offer. Okay, good offer to you, so that you can take the courses in a best possible ever price, which you'll never get. Okay, so target for today is, the session will be around for 60 minutes, I guess. Okay, session will be for 60 minutes. I'm here with the 20 questions. Okay, timer is running here. You need to answer the questions. Okay, and hit the like button, 100 likes, share this video and ask your friends to join the session. 100 likes reached means I'll give you a good offer. That's a reward you're going to get today. Definitely you're going to get. Okay, so session begins now. Let me start with the first question. What is this all about? In this series I'm repeating MCQs from electrical machinery PS Bhimbra and DC machines. Okay, so first question. Are you all ready? Good. Have you shared this video? How many of you shared this video? Thumbs up is not here. Don't give a thumbs up here. You need to like the video. I'll see the like count. Right now I see only 28 like count. Okay, it reaches to 100, then only we'll get it. Otherwise, maybe next time. Okay, let's begin the session. First question, are you all ready? Get ready with your calculator, because we're moving to the questions, right? And definitely, if I like your performances, keep watching till the end, keep responding to the video, keep responding to the questions. Then if I definitely like anybody's performance, then you will get a specific reward also. Okay, exclusive reward only for you. That might be possible. Do you have diploma in electrical engineering course online? See guys, we are electrical engineers. What the bloody fuck? Electrical means maybe diploma, maybe ITI, maybe BTech, maybe MTech, maybe PhD, anything. You want to master electrical engineering, then you are here. There are a lot of engineers who are working in field. They are contacting us. Okay, it doesn't matter whether you're from diploma background or whatever the background. You take the course, you will love the course. Anyways, I'm starting with the first question. Yes, I think 30 seconds is good enough. Timer is running here. Okay, did you see the timer? Timer is already running here. What is the answer? I want to see the answers. Quick. Ten seconds left. Good. Time's up. Yes, all of you answered correctly. Most of you answered, all of you answered correctly. Yes, you don't have to say multiple times. One time is enough. Don't spam the chat. Okay, one time if you answer it, that's enough. And I'll see if you are responding for all the questions. You be there for till the end, right from the beginning. Then definitely you'll get a chance to earn a specific exclusive reward. Okay. Manoj Rana, he's I think spamming maybe. He's putting a lot of see. Okay dear. Ashish Dangra. 4. Development of torque. Okay. Okay. Time's up anyways. Let me answer now. In DC machines, you place armature winding on the rotor. Yes, exactly, for the commutation purpose. These are question number 1 from PS Bhimbra book. These are question number 1. Okay, question number 1. So this is to get a commutation done. Commutator, tell me about the commutator. Commutator is a mechanical converter. I would like to say DC generator is equal to AC generator plus commutator. That is what a DC generator. AC generator, you add commutator to the AC generator, you will get a DC generator. And to get the commutation possible, commutator must be on a rotor. Okay, so if commutator has to be on rotor, obviously armature also must be on rotor. That's it. Okay, so answer is C. Who is saying something? I think, yeah, everybody answered. Most of you answered. Most of you answered correctly. Commutation 3, 3, 3, 3, 3. Current reversal. Commutation means mechanical rectifier. Sai Raghava. It's not a mechanical rectifier. To be more specific, it's a mechanical converter. It's a mechanical converter. Okay, tap current brushes are used. Tap current brushes are used. Okay, to tap current brushes are used. Okay, that's right. Okay, let's go to the next question. I'm moving to the next question. Are you all ready? How many likes? Share this video, hit the like button. I already given the challenge, 100 likes. Once we reach to the 100 likes, you will be getting a reward. You will be getting, all of you will be getting an open reward, 100 likes during this live session. By the end of this live session, we must get 100 likes. If you get it, you will get a reward. Get rewarded with 100 likes. Okay? Yes. Share this video. Share this video. Share this video. Second question. Yeah. For this, I think, let me give maybe 60 seconds. Yes, 60 seconds time. 60 seconds is not required. Yeah, but take the 60 seconds time. Timer is running already. Timer is running. Go, 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 go. Yes, answer is 3. You have answered already. Anusha Mohan. Answer is 3. Commutator is not possible. Action is not possible otherwise. Yes, somebody saying 4. DC machines are comparatively low rating machines. Okay. Four, 3, 3, 2. Subhash is saying 2. Bhargav 2. Kusuma 3. 2. You are getting different options. Okay. Yes. Time's up. Srivastava 3. Anil 2. We have mixed options. Let's see what's the right answer. Time's up. Anyways, in DC machines, the field system has to be provided on a stator, unlike synchronous machines. See, just now I answered for this first question. Armature on the rotor means field must be on the stator. If field on the stator, then only armature will be on the rotor, right? So it is linked, armature on rotor, because of the commutation. Here also, field is on the stator, then only armature will be on the rotor, so that commutation action is not possible otherwise. If it is not happening, if field is not on the system, if field is not on the stator, commutation is actually not possible. Answer is 3. How come you are saying Vignesh 2 is answer? It gives more uniform, see, whether it is on rotor or stator, the flux distribution will be same, just the same, because it depends on the air gap, right? So that's not the answer. So some people are saying 4. 4 is means DC machines are comparatively low rating machines. So what? Means who said first DC machines are comparatively low rating machines? Who the bloody hell who said that? It can be anything. We can have a small motor, we can have a big motor. You know, it's not necessarily it must be having a small motors. All DC motors are small motors. No. It can be small, it can be big. Okay. Like the video, and Diwali sale is already live. You can visit lectures.p8.in. Okay, take the course lectures.p8.in. Visit the site. You'll get best possible price you will be getting. Okay, and best course also. People are enjoying a lot. You will also enjoy. Okay, next question. Yeah, I think this question, I don't think more than 30 seconds. I given 36 seconds. Okay, take it. Answer it. 30 seconds is good enough for this. For high rating, losses will be more for DC machines. Sridhar. Okay. We'll come to that. Your point of high rating losses will be more for DC machines. You take the next question. Next question is done. C3. Somesh, Manoj is responding good, but he's responding multiple times. Bhargav is saying C. It's okay. Respond multiple times. What's wrong? Manoj is saying C. Vishnu is saying 3. Bhargav is saying C. Who is he? Bhakyasri is saying 3. Sridhar. Electric technology is saying 1. Sinusoid. Why sinusoid? How many of you did watch the video? Why sinusoid? How many of you watched this video? Why sinusoid? Tell me how many of you watched? Hariharan is also saying 1. Sinusoid. Why sinusoid? Why sinusoid in electrical engineering? How many of you watched that video? Have you watched that video or not? Respond to the question. I already given different Y series question. Why 50 Hz in India? Why sinusoid? Why 3-phase? Why 11 kV? There are a lot of Y series questions. Yes. You watch it. You watch that Y series question. The complete series. Y series is amazing series. Okay. Anyways, time's up already. So the answer is, correct answer is 3. Flat top. 3. Flat top. Sridhar, harmonics will be less. Sinusoid, no harmonics. What less? No harmonics at all. That's not the reason why sinusoid. You see, watch that video, you will get a lot of interesting insights. Yes. Aparna has said right. Dinesh has said right. RMF is best produced using sinusoid. Yes, that's true. Okay. Now, coming to this question. Okay, guys, stop. Let me get back to this question. The space distribution of area flux density wave at no load. See, this is a most important thing. Let me show you a figure. This is a figure. This is a most important figure. Okay. For DC machines, armature reaction, most of the questions you can answer just by using this figure. You have this figure in your mind, then things will be a lot more easy to answer. Okay, questions, you can answer the questions very easily. You have to know what is this figure, what is these lines. I'm not going to explain all these right now. You must be knowing it. Okay, so this is what main field flux density at no load. The red one is phi m, main field flux. Obviously, when there is no load. When there is a load, this is a armature flux. Okay, the green one is armature flux. Armature flux, main field armature flux plus main field flux. The blue one, phi m plus phi a, is the resultant flux. Now it is asked for no load case. During no load, phi a is 0. Only phi m is present, which is a flat top. One can say it as trapezoid also. Okay, this is question number 3. Flat top or trapezoid, you can say. Okay, let's go to next question. Take this maybe 60 seconds. You take this 60 seconds to answer this question. Yeah. Why it's not starting? Okay. Oops. We have here Yep. Timer is running. Timer is running. Answer this question. Four. Triangle MMF. Triangular MMF. Somebody saying. Shanmukh. Chandra Prakash is saying 4 answer. 2, 1. Dinesh 4. Somesh 1. Srivastava 1. Manusha 1. Most of the people are saying 1. Gautam 1. One. Most of the people are saying 1, but a few people are having a point of saying 4. Dinesh, Shanmukh. Okay. Let's see. Time's up. Time's up. Time's up. Time's up. Option 1. So, as per voting goes, Gautam China in motor DC to AC, in generator DC to DC. I think for the earlier question maybe. Okay. Time's up. Time's up already. So, what's the point we're talking about? Yeah, a commutator in a DC machine action. Oh, this is the question you're talking about, right? Half-wave rectification. Commutation is not a half-wave rectifier. Commutator is not a half-wave rectifier. It's a full-wave rectifier. It provides full-wave rectification. And of course, yes, it does convert from AC to DC. Exactly Gautam was saying. AC to DC in case of generator, DC generator. DC to AC in case of DC motor. Both. It does both. Provides controlled full wave rectification. No, uncontrolled full wave rectification. This is wrong. Yes, correct one is this. Okay. So how many, can we reveal the offer? How many likes we got? 67 likes only. Earlier, right from the beginning, we have only that many likes. Guys, share the video. 100 likes, you're going to get some reward. With 100 likes during this live session. Let's reach the target. Okay, question number 3, 4. This is a question number 4 is done. Now let's go to question number 5. Timer has begun. This is another interesting question. Let's begin again. Timer is running. For the question number 5, timer is running. Very good evening, Praveen. 72 likes, just 28 likes more to unveil the offer. 2 dislikes. Okay, let's see net likes, how many we're going to get. Srivastava, Nishant is saying 1, Srivastava is saying 4. Praveen, okay. Raghava is saying 3. Bhakyasri is saying 2. Priyank 3. Shanmukh 3. Okay. Time's up. Anyways, let's see this question. Most of the people are saying 3 and 1. 3 and 1. Most of you are saying 3 and 1. Okay. Okay, guys, focus here. This might be a little contradicting. Focus. In DC machines, the space wave of the air gap flux distribution affects. DC machine means it could be motor or it could be generator. Either way, in general we call it as a machine. Okay, it could be motor or generator. And air gap flux, if it is affecting the motor torque, means if flux is affecting the torque, definitely that will affect the generator induced EMF also. It's not that it will affect only in case of a motor, it won't affect in case of a generator. No, it's equally true. Whatever the effects you're going to get for the motor, same bloody effects you're going to get for generator also. So it can never be this option or this option. It is happening for true but not for induced EMF. No, no, this is not true. Now, either of these two is possible. Either of these two is possible. Okay. Space waveform of the air gap flux distribution affects, either if it is affecting torque, it will affect voltage also. If it is not affecting the torque, it will not affect the voltage also. Okay. Now, if I see this curve again, if I relate to this curve, here, this is the air gap space distribution. This is the resultant flux. This is a resultant flux distribution phi m plus phi a, and this distribution will lead to some demagnetization effect because of the pole saturation, pole tip saturation. This position here, this tip is getting saturated, and here this tip is getting saturated. Okay. So that's what TPT, LPT, trailing pole tip, leading pole tip, that's for generator, for motor, all these things you must be aware of all those. Okay. So due to this uneven space distribution, demagnetization effect will come. Okay, demagnetization effect will come because of the pole tip saturation. That will definitely lead to change. That will lead to change the torque as well as voltage. It will change both torque as well as voltage. Okay. If I ignore the saturation, careful, if I ignore the saturation, then yes, this will be the option. Here it is not said ignoring a saturation. So I am considering the saturation because saturation is present. It's not mentioned, so I am considering the saturation effect. That's why I am marking this option. Okay. I think we're good to go. We're good to go to the next question. Thumbs up, thumbs up. Give it in the comments so that I'll move to the next question. That will be mark. Somebody give a mark, dots, send something. Yes. Good. Moving to the next question. I got a thumbs up, so I'm moving to the next question. Yes. This is field flux, armature flux respectively long. I think for this 30 seconds is good enough. 30 seconds is good enough to answer this question. It's covering, uncovered. Okay. Yes, yes, yes. Go ahead, go ahead. We have a lot more questions. We have a lot more questions to go. A lot more interesting questions. Time's up. Time's up. Yes, this is an easy one. Video buffering, please do check your internet connection. 3, 2, 2, 3, 2. Some mixed options. Field flux along the north to south pole, that is direct axis but right hand thumb rule. So option 2. Okay. So now focus here. In DC machines, the field flux axis and armature flux axis are respectively. See here. Again this curve. Again this. Again this. This is a one. See how many times I used within this short 5 questions itself. I use this 3 times. Okay. See here. This is the armature MMF. The black one is armature MMF. This green one is armature flux. Okay. The axis of the armature flux is this. This is a peak point, right? Here for the MMF, this is a peak, right? So this is the axis of armature MMF. So interpolar axis. For the main flux, this is a phi m main field flux. This is axis. This axis is polar axis, or you can call it as a D axis, or this is called as a Q axis. Anything. Okay. So answer is D axis for the field flux, interpolar axis for the armature MMF. Clear with this? That's it. Who is this Hassan? Different emojis. Good. You're scaring me, dear. That ghost one. Okay, let's go to the next question. Yeah, how many likes we got? I said right now there is a reward offer going on, 100 likes. Once we reach to 100 likes, I will unveil a reward so that you will get to use that and you will get a good benefit. Okay, you'll get a chance to get a good benefit. So this is what? Question number 6. Let's go to question number 7. Are you all ready for the question number 7? Okay, go. So for this, yeah, I think again 60 seconds I'm giving it. I'm giving 60 seconds. Go. Yes, go ahead. Go ahead, go ahead. Go ahead with the question. Vignesh is thinking. Okay. Think. You have 20 seconds more to think. Not more than that. 2, tricky, 1, good. Boom, time's up. Tarun has said right answer. Abhilash has said right answer. Everyday live going. This is a live schedule. I think you can see the schedule over here, right? This is the schedule. As per the schedule, we'll go live. So answer for this question is yes, both. Question number 7, yes, it's a tricky one, a good one. Okay, both ED and TD are 0. Careful here, careful here, careful here. The best part of a DC machine, somebody was saying, we can't go for high ratings in case of a DC machines because of more losses. Somebody said that. DC machines is having a great advantage. The only advantage rather which DC machine is having, which no other machine is having. That's why still DC machines are still popular. What is that advantage? That advantage is field flux phi m and armature flux, armature MMF, and hence armature flux. Both are 90 degrees displaced electrically. You can see again from this waveform, both are 90 degrees electrical display. See, this angle is here, this is here, this is having here axis. So both are 90 degrees displaced electrical angle. Electrical angle is 90 degrees. So when you have this electrical angle 90 degrees between these two flux, this flux and this flux, then both are having, both torque is maximum, you will get maximum possible torque, and you'll get EMF also maximum possible EMF you'll get. Maximum possible EMF you'll get, maximum possible torque you'll get when it is exactly 90 degrees. Okay? And the second advantage which only DC machine is having is both are decoupled. Both are independent to each other. I can control phi m independently, I can control IA independently. Both are independent, both are decoupled. Okay? That is what another great advantage which only DC machine is having. And that advantage, we are trying to put that advantage into AC machines. We are trying to put that DC machine advantage into induction motor. That is what called vector control concept, which you will study in higher studies. Okay? That is what making induction motor so popular. That is, we are trying to imitate the induction motor like a DC motor. Okay? So now it is already having 90 degrees. Now what I had done is I have rotated the brush axis by 90 degrees. I have rotated the axis by 90 degrees. Means what? Maybe this and this both are in the same phase. Okay? Both are in the same phase or maybe anti-phase. The angle between these two is once it is rotated 90 degrees, both are either 0 degrees or both are maybe 90 degrees, both are maybe 180 degrees, both are opposite, okay, or maybe both are in the same direction because they are rotated 90 degrees. Then absolutely both EMF will be 0 and torque will be 0. If you go to more technical details with the help of this diagram also, you can answer this question. Armature reaction concept if you involve, yes, you can answer this question. So answer for this is finally yes, this is a 1. But the process, the process which is involved here, the understandings are very important. Okay, I think we're good to go with the next question. Yes, let me read. 100 likes crossed. Okay, that's great. 104. Yeah, good. Dear, now as I said, 100 likes. I'm going to give you a reward, and I saw some good responses. So the offer is right now, Diwali sale is going on with the courses. Okay, right now Diwali sale is going on. You will get already 50%, up to 50% off is there already on the courses, up to 50%. If you use Diwali coupon, exclusive coupon code, you will get plus extra 20% off. Okay, now I will share a coupon code, okay, where you will get, should I unveil? I like your responses, so I'll make extra 0, no, not 0, extra, how much should I give? Extra 40%. Yes, I'll give a coupon code. I'll give again in the middle of the course. I'll see at right moment after crossing some questions, few questions, I'll give a coupon code. Okay, if you use that coupon code, you will get extra 40% along with the existing price, reduced price, you'll get extra 40%. Okay, so because we reached that 100 likes, so yeah, and I like your responses also. Otherwise, if you would have not responded, then I would have not given 40%. But your response is good, that's why it's 40%. Now let's go to the next question. Are you all ready, guys? Sir, your teaching style is awesome. Thank you very much, Mr. Kuladeep. I understand all these things. Good. Once you take the course, there are a lot more animations here. I don't have that freedom to involve good animations. But in the course, my team is there. They will make sure all the animations will be very nicely kept. Okay, let's get to the next question. Question number 8. Question number 8. Wow. I think, let's see if you answer this question. I'm giving 2 minutes to this. I'm giving 2 minutes to this question. If you answer this question, then I'll give an exclusive coupon to you. Not for everybody, for only one person. If you answer this correctly, I'll give an exclusive coupon for one person. Have you left? Smart, Ashwin. That was not a full association, Ashruth. That was a short association which we made that time. So they were asking me to extend the contract, but at that time I was not interested. I was not having time. So yeah, that was. If now I'm completely engaged with this PiSquare, I'm unable to give time for my darling, my lovely darling, PiSquare. So yeah, it's getting tough. 1 ampere, 1 ampere, 1 ampere. Nice. You have time, guys. You have time, guys. Think and grab an exclusive offer. I like Ashruth. Good point. He didn't spam anything. He didn't spoil anything. Smarter. Smart. Ashruth is smart. Option 1. Raju is saying option 3. Srivasa is saying option G. It's option 1. Okay. You have 15 seconds more. Time's up. Bam. Time's up. Time's up. So, Tarun has said 5 ampere. Priyaraj has said 3 option. And Manoj has said 3 option. Razu has said 3 option. So does your course P and machines contains PYQs? I wanted to purchase, that's why I'm asking. Yes, Shanu, you have everything best you can get from the course. PYQs, MCQs, all the best packed, power packed course. People are enjoying a lot. So, yeah, the first guy who said the answer is Razu, then Manoj, then Sridhar is also saying correct. Priyaraj has also said yes. The correct answer for this is right 5 amperes. So whom to give the offer? I said yeah, Raju. He responded much faster. Tell me, Raju, how did you calculate? I want to give it to you. Exclusive coupon. Tell me how you got option 3 as right answer. Give it in the comment. Those who said that, those who said correct, give it in the comment how you got it. Then we'll go with you. Okay. Wow. Srivastava said clearly things are equivalent. Blah blah blah. 5 into 1.5 by 1.25 plus 0.5, 5 ampere. Not bad. Okay. Okay, guys. Let me get back. Meanwhile, those who said because we have an exclusive coupon. So yes, Manoj is a winner. Manoj, you give me your email ID. I'll give a coupon code for you. You are the winner of this question. Question number 8, Millimus theorem. If you apply the Millimus theorem, that's it. That's the best one. That's a good application. Of course, everybody said right. But yeah, I had to give it to only one person. So Millimus theorem. So Manoj, give your email ID. Nothing to worry, it won't be visible on the live stream, but it will be visible to me. Okay. Give your email ID. Yes, I got your email ID. Okay, I got your email ID. I'll give an exclusive coupon code just for you. Okay. Okay, let me come to the answer. Add up 4, so overall 7.5 only. Okay, let's see. See, it seems to be a network question, but how nicely this Bhimbra, the questions are really good. Okay, how nicely the networks question is related to DC machines. Here it is said 5 cells are connected in series in a row. Okay, 5 cells, 1, 2, 3, 4, 5. 5 cells are connected in a row in series. And 4 such rows are connected in parallel. This is one, like that, 4 such rows are connected in parallel. That's what? 4 parallel paths you can read for DC machines. Okay, each one turn you can take. Okay, you can consider like that. Anyways, and they're feeding to a load. There is a load which is connected. There is load which is connected here. That is what? How much is that value? Load value is 1.25 ohms. Okay, 1.25 ohms. Now each cell is having 1.5 volt. Each cell is having 1.5 volt with a resistance of 0.2 ohms. Okay. Now tell me, all are in series. 5 cells are in series. What is the total voltage? It is 7.5 volt. What is the total resistance? That is 1 ohm. So I can consider this as 7.5 volt with 1 ohm. Like that, we have 4 such things are present here. Okay. Now it is connected to a load of 1.25. 7.5, 7.5, 7.5, 7.5, 1, 1, 1, 1. If you apply Milliman's concept is evolved from the Thevenin's only. Okay, if you apply Milliman's theorem, then you will get this as 7.5 volt, this as 0.25 ohm, here you have 1.25 ohm, so the current will be 5 ampere. Answer is 3. Okay. Yes. Let's get to next question. Manoj Kumar is a winner. He will get an exclusive coupon at the end of the course. Okay. Next question. Let's go to the next question. Question number 9. Are you all ready, guys? Are you all ready? Have you shared this video? Share this video with your friends. Share this video on WhatsApp. Share it on Facebook. Share it on bloody any social media. Okay. Now, yeah, move to the next question. Let's get in. Yeah. This question, you take again 2 more minutes to answer this. 2 minutes, I think, yeah, it will be a little bigger. It's not required to have 2 minutes. Take 2 minutes, okay. One, two. Rahul is saying 2. Sai Kiran is saying 1. Abhilash 1, Rahul 2, Sagar 2. Srivastha 1 and 4 option number 1. Okay. Ashruth 1, Omkar 2. Yeah. I think 2 minutes has become too much time. I should have gone 90 seconds. Anyways. Okay. Okay. Let's get to next question. Let me explain this question. Then I'll go to the next question. 10 seconds more. 10 seconds more. 10 seconds more. This is question number 9. Bam. Time's up. Yes. This is the right answer. This is the right answer. Option number 1 and 4 are right. Consider the following statements regarding magnetizing characteristics of a DC generator. Okay. Some people are answering variation of open circuit. So let's come to this. It represents a variation of, which option is correct? I'm saying 1. No. This is not correct. How come I said this is correct? Yeah, let's get back again. Magnetization characteristics of DC generator. Magnetization characteristics. It represents the variation of field flux and field current. No, DC generator magnetization characteristics or open circuit characteristics means what? Variation of open circuit terminal voltage with field current, with respect to field current, and it is an independence of speed. It doesn't depend on speed. Yes, this is right answer. This is correct option. Okay, multiple select questions. Okay, you need to select, if these are options are not given, you need to select which one is correct. Multiple select question. This is a correct one. Then next, magnetization characteristics is it's non-linear from 0 to rated field current. It is non-linear from 0 to rated field current. No, it's actually, if you see the characteristics, it is linear in this zone, it is non-linear in this zone, right? It is linear here, it is non-linear here. Okay, let's keep it aside. It helps to determine the critical field resistance at a given speed. Yes, we can find out critical field resistance by using this. This is right. Okay, it always starts from the origin. I think option 4 is there. There is an ambiguity in this. It's not always starts from origin. In case of DC generator, it might start from here also. It might start from If it is separately excited, then it can start from 0. If it is self-excited, it has to start from here. Okay, so this cannot be the answer. So answer is, it represents 2 and 4, but we don't have that option 2 and 4. Yeah, what can we do? 2 and 4 must have been there, but it's not there. Okay, but yeah, this is wrong, this is wrong, this is wrong, this is the correct one. Okay, 1 and 4, how come 1 is correct, guys? People are saying 1, how come 1 is correct? Magnetization characteristics or open circuit characteristics, they are, oh yeah, field flux with the field current. Magnetization characteristics is not field flux, it's an induced EMF. Induced EMF versus field current. That's what magnetization characteristics or open circuit characteristics will call, right? Variation of open circuit terminal voltage with the field current and independent of that doesn't depend on speed. No, it does depend on speed. How come it doesn't depend on speed? It does depend on speed. How I'm saying this is the right answer? Because see, magnetization characteristic, speed is more. I'm sorry, I'm in some other mind. I think I lost my mind maybe. If it happens sometimes, it happens sometimes. Just a minute. I will change the AC temperature a bit. Yeah. So if speed is less, magnetization curve will be something like this. If speed is more, magnetization curve will be something like this. Okay. I think if you go with the options, because we have options here, according to the options, if you had to go, because as per my analysis, this is definitely wrong because it depends on speed. This is wrong. Okay. We already said this is wrong, we already said this is wrong, we already said this is wrong. Okay. Now, as per the options, only 4 is here. So 1 and 4 options. So I can consider magnetization curve or BH curve, magnetization curve or BH curve. If we consider it as a BH curve, then yes, it is flux here. We can take it as flux here. Okay. If you consider it as an open circuit characteristics, then it will be different. So I have a convenience now. I have to, because I have options here, I'm choosing this option. That's more relevant because I had to choose one option here, right? So I'm choosing this option by considering this is a BH curve or magnetization curve. Okay, magnetization characteristics. But usually, in case of a DC generator, we call open circuit characteristics or magnetization characteristics, no load characteristics, all means the same. Usually that's what we consider. Anyways. Let's get on to the next question. 4 is correct, so next option 1 convinced me, so somehow said option 1. Yeah, you're right, that's what. BH curve forms a closed loop. Yes, you can consider, it's not BH curve will always form a closed loop. Hysteresis loop will form a closed loop. BH curve is, it's a curve, okay? That's what the difference. BH curve we can call, or magnetization curve we can call. If I say hysteresis loop, then that's a loop. Okay, hysteresis loop. That's also definitely between B and H. That's true. But we're taking a loop, a complete cycle, continuous cycles we're taking. That's how it is, hysteresis loop. Anyways, yes, you're right, Gautam. You did good. And question also, dear Hashmi, your question is right. Next question number 10. Yeah, for this I think maybe 60 seconds is enough. 60 seconds is enough to answer this question. Just to read the question you need some time, but to answer it I don't think you require any time. Yes, now I think you can see. Those who has joined recently, have you stopped liking the video? You can like. What's wrong? Though award is given, you can like. Yeah, I'm going to announce. Let's end this live session here after this question. I'll end this live session and I'll give you the coupon. Use that coupon. then you'll get that offer. You can take that offer. Okay. And exclusive offer, Mohan has got an exclusive deal today. Swagger option. Time's up. Bam. Okay. Time's up. Before going to the answer, let's come to this. For 5 users, okay, today at 10:30, not 10:30, 9:30, let's go for 10 p.m. The offer will be live at 10 p.m. today, okay. Take a note, write this coupon code, take SPCL40, use coupon code SPCL40 today at 10 p.m. for 5 users, lovely YouTube users, 5 users, you will get extra 40% in all the courses. Complete website you will get 40% coupons, okay, 40% discount extra. At what time? 10 p.m. coupon will start for 5 users, limited users only. Done? Okay, let's go to next question. Thumbs up guys, thumbs up, cheer up. We guys need some entertainment, not entertainment, motivation maybe, yeah, motivation. Thumbs up, give it a thumbs up in the chat box. If you already like the video, give it a thumbs up in the chat box so that before my team leave here, a person is waiting for me, so he leaves, he'll be motivated a bit once he sees a little more likes. Okay, yeah. Okay, answer is yes, answer is right, exactly this. Careful here, there is a point to note. DC generator builds up a voltage of 220 volt, okay, at no load while running at rated speed. When it is rated speed, it's 220 volt. This is a statement, we understood the statement. Now next, if the speed of the generator is increased by 25%, keeping all other circuit things are same, we have not changed anything except the speed, then which one of the following will be true? Speed is exactly proportional, or EMF induced is exactly proportional to speed of the rotor. No saturation, nothing will touch this. If it is flux, suppose if the same thing is given, flux, field flux is increased by 25%, then tell me what will be the option. Then the option will be this one, increase to value lying between 220 and this, between this. That would have been this if it is flux increase, because there is a saturation. BH curve just now we had drawn here, BH curve, magnetization curve, saturation is setting in. That saturation will not allow the current to go, or the EMF to raise much proportional. So that's in between this. But if it is a speed, yes, it will increase proportionally. So the answer is exactly this. Okay, don't get confused between flux and speed. You need to be clear with that. Yes, others, chill. Let me end this session. We have a good session today. We had a nice session. Let's end the session. Thank you all guys. Thank you all for joining. If you are new to the channel, subscribe to the channel, share this video with your friends, invite your friends. We have a lot of interesting questions we'll be taking up. If your involvement is good, if your engagement is good, then we'll try to continue the sessions every day. Yes, enjoy the Diwali tomorrow. Have a safe Diwali. Be careful. Be careful. I know you will be careful. Okay, I don't have to say all these bullshit things. You already know, right? You're smart enough to do all these. Okay, that's it. Let's end. Don't forget to check lectures.pi2.in for the courses. Okay, you can check this and enjoy the courses. Okay, thank you all. See you again in the next live session.